So who is doing the chair's slide?
Well, you asked first.
Whatever.
Whatever.
410, starting the DTN working group session. Blue sheets are going through the room. As usual, we're under the note well, which says essentially, everything you say or you write is covered under those rules. Please read when you have time. Proposed agenda that my colleague Rick has put out from the call for proposal. I guess we ought to get some convergence layer done. We had discussions with the AD this morning and the outgoing ADs, and we would like to get this done ASAP. Any agenda bashing or changes?
Do you want to cover the decision that was made with the AD that we're going to proceed with the two?
I don't think so yet. Yeah, I think we should let. Yeah. No change to agenda. Okay, Ed, are you still available to take notes?
I love taking notes.
You take very good notes.
Excellent. You will be presenting.
Yes.
Therefore, we would like to have another note takers during at least the time where Ed is going to present. Any volunteers? Should I point someone? When someone comes to the front and shake hands with the chairs, then you get a token of being the note taker. That's for the thank you.
Don't do it. Ed, are you going to use Etherpad for this, or are you going to just type it in a notepad on your laptop? If you use Etherpad, then Martin could pick up on it. But
I have not in the past. I could try and figure it out. I just have at the moment.
Okay, well, just whatever works for you because you volunteered.
Yeah, we've done last calls. I don't know if you remember that we did, but we did. And well, convergence layer, TCP conversion layer being discussed. Hopefully, the last time this week, we'll progress to sending to the ISG for our AD for his new work. Just as an introduction to his new tenure. That is the milestones that we had agreed a while ago to work on. We, on purpose, use a subset of them because we want to focus on the base spec, which is the revision of 50/50, but then other stuff needs to be done to get a full solution. Having said that, I think next is Scott. Okay.
Okay. I'm Scott Burley. I work at the Jet Propulsion Lab in Pasadena, California. We're going to be talking about minimal TCP convergence layer adapter. I can be very brief. I've got exactly one slide. Let me just go ahead to that slide. The intent of MTCP CL is to provide a convergence layer adapter that is simple enough that we can agree on it readily and provide it along with the BPSec specification and the BPBIS specification as a package so that we can start moving everything together onto the RFC editor's queue. To that end, the MTCP convergence layer adapter is very short. It's about 8 pages. You can review it in about 10 minutes, I think. We talked about it a little bit at the last IETF. Since then, the only changes are, first of all, changing the name from simple TCP convergence layer to minimal TCP convergence layer. That seemed to be more acceptable to everybody. It was, and the working group also adopted it. So the name now has got DTN working group in it, I think, instead of me. The second, and really the only really significant change was adding language about establishing TLS sessions in the same way that TLS needs to be supported in the TCP convergence layer. And in fact, the language that I added there is lifted, well, not exactly verbatim, but very pretty close to verbatim, lifted from the TCP CL document that had already been compiled, and I'm assuming that's all going to be workable and acceptable TLS language. The only other change that I made in the document as I was going through it was there's one point where describing the structure of the MTCP protocol data units. Something had come up in another context that there was a possible ambiguity in saying that the encapsulated bundle that was being shipped in the MPDU was a CBOR byte string. We wanted to make it clear that it was a CBOR byte string of defined length rather than an undefined indefinite length CBOR string. Those are the only changes. The revised updated spec was posted as an internet draft on the 28th of February. And at this point, I leave it to the working group as to whether or not we can go ahead with it. Any questions?
Any questions? Okay, let's, could you take care of this?
Yep.
There's one.
Hi,
Right.
this is Brian Siebes
Go
from
ahead.
RPF. I was looking into the MTCPCL and also the bundle protocol v7, and I ran into just a rough question for the working group as far as the policy of CBOR tagging. I noticed that tags are mentioned in BPv7 and not really in the TCPCL. Is there a policy as far as like tags just shouldn't be present at all in these CBOR encodings? Has that been thought about or looked at all? I'm just wondering from the perspective of interoperability and troubleshooting and message dissecting.
I'm not sure I have an answer for that. The intent in both the BPv7 spec and the MTCP spec was to state all of the CBOR representational elements that were required and nothing else. So there's I think no intent to say that you can't do anything else in for example an extension block, but I think both specifications are silent, and I will declare intentionally silent on that question unless there needs to be something said about it.
Scott, Rick Taylor here, as a personal comment. I seem to remember, and I'm sure a CBOR expert will correct me if I'm wrong, that the specification of tags in CBOR is that they are to be parsed as effectively metadata, but do not affect the actual fundamental data that's being transported. Whether a tag is there or not doesn't manifestly change the meaning of what you are parsing. Sure, if you're doing a wire dissector or trying to do this in FPGA, then it's an issue. But I think if you want to tag that this string is a date, that's useful perhaps for your domain. So I'm not quite sure where I'm going here, but I'm not sure the presence of tags needs to be specified canonically within the specification.
And I agree. And my question was just to make sure that from the perspective I was looking at of dissecting messages is, should I bother to care and skip tags? And the answer is yes.
I think the CBOR spec says you should. What you do with the tags is your business. So if you just throw them away because it's irrelevant to what you're doing, that's fine. But I think to be a compliant CBOR consumer, you must handle tags. Okay. But we'll have to go to the actual CBOR spec to determine that must or should.
That sounds right to me, and it's certainly fine with me and consistent, I think, with the specifications, because the specifications don't say you can't do it. So I think my intent has been to define stuff fully enough in the specification that tags are unnecessary. And I think I would stick with that intent, but if somebody wanted to insert a tag for some purpose, I don't see any objection to it.
Okay, thank you.
Anything else?
Felix Walter, D3TN. So just another short question about the PDU. So I saw in the document that there is a length value before the CBOR byte string, which represents the bundle.
Yes.
So isn't this kind of redundant? Because the CBOR byte string itself has a length encoded.
I think if it's a well, I don't know. Have we?
We've gone around this about 4 times, and I
think we had this at some point
in
the bundle protocol spec.
We've gone around this 4 times, and I can't remember why we've gone back to having it. That somebody should have had some notes on this. This may have been a conversation we had in a establishment serving alcohol, which doesn't help.
It's possible. It's possible.
If I remember, was it something to do with somebody had a situation where the parser they were using wanted, is this the indefinite strings thing again, where it's trying to load the whole thing into memory, and if you've got a 2 gig PDU, you might not want it in memory.
Actually, this was one of our problems when writing the serializer. So I think because the BP BIS spec said that the length value should be the length of the serialized part of the bundle block data. And for that, you first had to serialize the block data to determine the length.
Yeah.
And the length itself was of variable length depending on its value, and so it was difficult to implement this in a streaming serializer.
That's right.
So yeah, but I don't think this would be a problem for the MPDU, because it says that the length is the length of the encapsulated binary bundle.
Right.
But I think it would still be redundant, and it was just a question why this is needed. I mean, probably I oversee something there.
It would have been great to have this question on the mailing list before we got here. Yeah. I would have to research in CBOR to give you a better answer. But I will say that I'm perfectly fine with removing the length field from the protocol data unit. That's if it's not necessary, great, let's lose it.
Rick with chair hat on, sorry to interrupt.
Thank you.
This is a classic mailing list conversation, and can I recommend we do this properly on the mailing list so there's a record of why we came to this decision before we get asked again in 3 months' time, probably by the same people again because we've forgotten.
Yeah.
So definitely take this onto the list, please, guys.
Anything else?
Yes, Mark here. Well, I think we should do machine learning to solve those problems.
Out.
So we potentially have 2 TCP convergence layers. In the TCP over IP world, then we will connect to a port number. The TCP CLv4 has a port number.
As part of the negotiation.
No, it's a port defined.
It's a predefined port number.
Yeah, IANA port services registry. 44556.
Oh yeah.
So
RFC 5050, I think, had that. Yeah.
Yeah, that was So if I'm using your transport, which port am I using? And if it's the same, then we need some kind of a
right.
way to.
It ought not to be the same. It ought to be a different one. The spec is silent on that.
Yeah.
It says it's established by management. I will observe that this is in operation 24/7 now on the space station. It can be made to work. It is being made to work. It's not an insuperable problem. If we need to define a port number for it in IANA, I'm perfectly fine with doing that. But it certainly is different from the port number that would be used for the TCP convergence layer.
Well, that's my point. Either we use the same port and we have a way to identify which protocol we're using, or we use another port.
And I completely abjure the former, right? We're not doing that. We're not using the same port. We're not.
That's fine, but
We're not
either
doing
way,
some sort of disambiguation.
cool. Either way, your spec is silent about this, right?
And if the spec needs to say something about it, that's fine. We can establish a port number and put it in the spec. That is perfectly fine.
So, Rick Taylor here. Spinning to the top of the document just to check. So the latest draft is standards track intended.
Yes.
So I'm looking at the AD for advice here. For a standards track document, we ought to have an IANA request for a reserved port.
It doesn't.
I think so. You think so. And Magnus is going to tell us something different.
No, Magnus Westland. So I mean, if you actually want to request a port, yes, you need to have a IANA section on it. I'm not. We try to keep down the port usage if it's really. I mean, and we shouldn't be spending a lot of ports if it's not necessarily. I don't understand enough about this case to give a recommendation from standing here. But do you have other methods of figuring out, or is it local configuration for which convergence layer you're using, etc.? You might not need you can use a dynamic port for that each particular. Or how do you find your bundle and the convergence layers?
The intent of the specification has been that it's a local configuration matter, and it's up to it's managed outside of the protocol, and it doesn't have to be a part of the standard.
Yeah.
We don't have to do it that way. I'm happy to find a port if somebody wants to reserve a port for it.
I would recommend against reserving a port unless you really need it, and so.
So Rick, responding to what we've just heard, I personally, not chair hat on, personal hat on, I'd be perfectly happy to see some text in the document that says we don't need to reserve a port for this. It's a minimal TCP/CL. Pre-configure it in some way out of band. And as long as that text is in there, then fine, let's proceed. But I
there's-
can't see any.
There is text that says it's established. There's text that says it's established out of band. There is
I missed that.
no text that says there's no need for a reserved port number, but that's an easy thing to add.
Jörg, given the different encodings, wouldn't it be obvious or fairly obvious for a receiver to figure out whether this is a TCP-CL or a minimum TCP-CL packet, so that you can at least fail safely or in kind of a reliable way determine that you have a convergence layer mismatch at least on one end, so that people could actually mux the two protocols on the same port?
That was my question before.
I guess I would advocate against trying to mux the two protocols on the same port. I don't think there's I don't see a significant operational advantage to doing that. And if you're not going to do that, then I think it's unnecessary to require implementations to be able to distinguish between the two.
Or given that the first few bytes are different, how much do you have to do?
Yeah, but the first few bytes are a length and then some payload. So I could craft something that looks just like a TCP/CL header, but is actually a specially lengthened packet. I think that's a can of worms, personally, I wonder about. Sure, you can write an implementation which does both, and that's great. But
I think it's a... I think it's simpler.
We have plenty of experience in the internet that things tend to get misconfigured occasionally, intentionally, across all the broad routing protocols. And so this is all I'm just saying. So if we have some minimal wisdom we can provide in the specification, then that should go in there, and that's it.
I think you can certainly use the specification and infer from it sufficient wisdom to do an implementation that distinguishes between the two. I don't think there's anything to add to the specification itself to make that possible or necessary.
Rick, jumping in again. What I could hear there is what Jörg is proposing is perhaps this specification, and we'll need to check the TCP/CL specification, is there a unique enough header or preamble on the connection establishment such that I know there's a version number in TCP/CL. Do we need to put a preamble, an MTCP in ASCII or something on the front end so we can say, oh, someone's pointed their web browser at me by mistake? Or I'm looking at the room for feedback on this. Because Jörg makes a point, everyone misconfigures everything, but is it then their problem rather than the protocol specs problem?
I think the protocol will fail as soon as it starts running because it's because of the misconfiguration, and you could infer from that misconfiguration that there's a misconfiguration. Adding protocol elements that help you distinguish exactly what sort of misconfiguration you've got can be done. My personal preference would be not to do that.
Hello, Ron Infeld. I don't particularly care what you do, specify a port number or not. At least as you say something, I agree with Mark Blanchet there. However, I would very much like TCP/CL to have a port number, and maybe reuse the 4556 for that. And I see MPTCP TCP as a sort of a stopgap for now. And still, sorry, TCP/CL v4 as the real thing.
Yeah.
Thank you.
And I'm perfectly fine with that. The intent of the MTCP/CL specification is to get us something so that we can move forward.
Last question.
Ed Brain, just a comment, which was, I think the value of having both of them is that the minimum TCP/CL stays minimum. And so I think while there are many features that could go into it, having something that is really only that which is necessary to show what we need to for bundle protocol is the rubric for determining what goes into MTCP.
I agree with that.
Thank you, Scott.
Anything else?
Nope. Brian?
When you're ready, Brian. Thanks, Brian.
Okay. So I have a very few number of slides, and the summary version is that this is very close. So the first couple of slides, can we skip to the next? No changes have been made to the background. This is just for a copy of some of the earlier presentation. The point is to update what already exists and to make what already exists in TCP/CL v3 simpler and more robust where it was possible, and add extensions for the benefit of the protocol. Can you go to the next slide, please? So still, the goals are to not change the scope or the workflow. The CL works in v4 much the same way as it did in v3. There's still the same phases of negotiation. There's still the same message headers and message type codes. And so ideally, this would make it easy for an implementation to be adapted to move to v4 or to be cross-compliant with v3 and v4. Next slide, please. So the last edits in the draft, based on feedback from George and the other IETFers, was to completely remove the transfer init message, which originally was present only because of compatibility issues in the TCP/CL v3. And I'll talk a little bit about this in a couple of later slides about PDU size. So the extension items, which were present in the transfer init message, have just been moved into the first transfer segment message, which is identified by a start bit. So this simplifies the state machine. It reduces some PDU overhead. And I'll talk about the transfer total length. But this is also moved into an extension item for a simplification of the sequencing and reduction in the message size. The total extension item length has been reduced from 64-bit to 32-bit. There already was some guidance in there about make your extension small. A 32-bit total length enforces small to an extent of fitting into still a relatively large bucket of available size. But the intent here is for extension capability. So 32 bits allows a lot of potential future stuff. The default and minimum session timeout was clarified to be compatible with the recommended values from the CLv3. So there's no change from v3 here. And then a reply bit was added to the session termination message just to avoid a feedback loop. So whichever entity, whichever peer of the session sends the first session termination, the reply bit is not set. When the reply message is sent, the reply bit is set. So there's a clear sequencing of the session termination. And in a valid session, there's only ever going to be one session termination message coming out of each peer. One of them is going to be initiation, and one of them is going to be the reply, and that's it. And then the session termination encoding was simplified to avoid variability of the message content. Now, instead of the type code being present or not present, the code is always present, and there's just an unknown type code. So this is all simplification. And then this hasn't been presented before, but I'm just bringing this up to show how small you can get TCP/CL v4 as a reference for thinking about it. So in a very low end implementation. This is not a greatly compatible one, but this is one that if you had a controlled network that you knew what was going on, you wouldn't use TLS, you wouldn't need to exchange EIDs, so those would be empty, and you wouldn't need extensions. And if you wanted to use always single segment transfers, then these are some of the numbers. And the summary version is that it's 33 octets to get a session running, and it's 40 octets of overhead beyond the actual bundle itself. So this is the level that TCP/CL is working at right now, just as some numbers to think about in the context of how big are these overheads relative to how big are the bundles being transported. And then in the sequence, I break down the individual items, but you can review this. So the transfer total length was moved into an extension item. And the reason for this is for a couple of things. One is to allow that minimum number to be a bare minimum. If you do want to do single segment transfers, then the total length becomes redundant because it's all in one segment, and the segment already has a length. And also moving this out of that separate transfer init message into an extension item, although there is some overhead with the extension item, the overhead of the extension item is actually 2 octets smaller than the overhead of the transfer init message. So there's no overall penalty for doing what was been done here. And this simplifies the sequencing. And it actually brings the TCP/CL4 into more kind of logical alignment with how V3 was structured. And even when the transfer length extension is used, it still only adds on the order of like 15 octets of extra message size. So separate from the protocol itself, this is more to do with interoperability and working code side of things. The example agent that was done in Python has been updated for the draft revision 11 message sequencing. And there's some other embellishments that have been made just to show what can be done with the V4 protocol. It now does graceful session termination. And this was something that, as a proof of concept, as a kind of a justification for some of these behaviors, I wanted to do this because there had been some questions coming in about the initialization and termination sequencing. So this just gives some concrete evidence that yes, this is a workable behavior, and it does provide actual value to the protocol. And also as a proof of concept, because it was something that had been discussed, but it wasn't really looked at, I don't think, at all, is the agent actually has a feedback algorithm to have adjustable segment size to hit. In this case, the target metric is time to acknowledge, the difference between the time when the segment is being encoded and when the acknowledgement comes back to that segment. And operationally, I think this is the kind of thing that an agent really would be looking for. Is you want to guarantee that your unacknowledged chunk of data is going to be no more than X number of seconds old on a whatever your speed network is. And I also implemented just this minimum message generator to exercise the demo agent. Next slide, please. One other thing that was done, again, just as justification for the protocol itself, was I put together a Wireshark dissector, and it really exercises, I think, all of the behaviors in the V4 convergence layer. It supersedes the stock Wireshark dissector that was called bundle, and it was the TCP/CL v3 behavior. But this handles all the messaging. It handles actually TLS within sessions and reassembling of individual transfer segments into the total transfer data. So I think for interoperability and for example of working code, this is a pretty nice thing to have. And then I also did some minimal implementation for the bundle protocol itself, but very basic stuff because I wasn't really focusing on that. Next slide, please. Here's just a picture of some of the dissected CLv4 messages. I mean, nothing should stand out if you use the dissector like Wireshark before. But again, just a matter of justification for is a realizable thing, and is it a reasonable thing to be organized the way it is. And nothing in here, nothing in the protocol itself actually was too complex of a thing to put together with the way that that Wireshark is structured. Next slide, please. So the one open issue that is really just a matter of opinion and how much future use extensions are expected to get is each individual extension item right now is sized so that the length field is 32 bits. That's certainly more than would be expected to be used in any individual extension item. There was a comment about reducing the individual item extension length to 16 bits. Is it worth? This is a question to the working group. Is it worth shaving 2 octets in an optional PDU to reduce the size of the extension items? I don't see any real strong blocking reason for or against, other than reducing the extension items by 2 octets. If an individual extension needed to encode data longer than the 16-bit size would allow it to do, then the extension would have to define, well, if you want to encode this, then you have to have multiple items, and then they get stitched back together somehow, because items can be in multiples and can be in sequence. So it's not stopping anything large from happening, but it makes it more complex on the extension to do so. But even oh, go ahead.
Sorry, Rick Taylor, quick question here. On the size of the extension item data length field, what was the vision of the authors when they were putting together the extensions of what they felt an extension was? It was a small chunk of metadata, or was it a whole separate big blob of something? Because I think that kind of guides whether you're in 16 bits or 32-bit land.
My concept originally of extensions was I had put more of the negotiated data into extensions. So some of the EIDs and some of the individual small parameters, and even EIDs being related to URLs have processing limits that are in the order of, I expect, thousands of octets, not single-digit thousands, not hundreds of thousands.
Okay, thanks. Yeah.
But yeah, it's really intended for metadata associated with potentially information about things that wouldn't be part of the bundle itself, to do with sequencing or priority or small stuff.
Rick, again, that sounds a lot like 16 bits is what you're suggesting.
And yeah, I really have no problem with saying 16 bits, and if you need something larger, you figure it out yourself.
For your reference, I'm seeing a few nods around the room in here, but that isn't any indication of consensus. This might be a question for the list.
Sure.
Is there another slide? Yeah.
Yeah. Well, this is just the last one. Just the current status is I do have some last set of typos, copy and paste naming type things to fix. I did see that there were actual reason codes, numeric reason codes included in IANA tables, but not in the actual requirement body tables. I think it makes sense to include the reason codes in both, just because you don't have to jump around between different spots in the document to look up if you're trying to implement this thing. But it's not any new data. It's just a little bit of redundant information in the spec. And then, like I was just talking about, there's both a working implementation pending any changes in the encoding, a working implementation against the -11 version, and a working dissector in Wireshark that are available at the same place. So I think it's at least a good position to say, yes, this is a fully functioning, and as somebody had brought up earlier in the discussion, backwards compatible in terms of being able to, and there are procedures in the spec about how to interoperate with the TCP/CLv3 on the same port.
Brian, so your latest change, do you have an agreement with your co-authors about them? Please say it on record.
Yes, we do. We have been heavily in touch.
What is your name?
Jörg. So yes, we agree.
Can you sign with your blood?
Not in the IETF. That's too dangerous.
Okay, so apart from small changes and the length of that field that you described, do you think it's ready for going to the ISG, right?
Yes, I believe so.
The answer was yes.
Can you say again, Brian? I didn't.
Yes.
Can you say again, Brian?
Cool.
Yeah.
Yes.
Do people in the room think it's ready for sending for publication, or do anybody think it should not go to publication? No comments? You don't care? Tired? Anybody oppose? Okay, so I guess we're going to. So Brian, if you could, like in 1 week, get the final version so we can forward it to the ISG with the bundle of the other specs. Ed, you are identified as the document shepherd, so we would be looking for the shepherd write-up. Cool, thank you very much. Are we, Scott? Are we ready for sending your document for publication too?
Could you come to a mic?
I would say yes, it's ready to go ahead for publication. If discussion on the mailing list uncovers need for a small change, that's an easy thing to do, and could be done certainly within a week if we decide that.
Okay. Do people in the room think we should also send this document for publication? Yes, no, maybe. Yeah, okay, some nods. Okay, cool. So our beloved AD, you will receive 2 convergence layer. That's Christmas for a new AD, right?
So having said 2 documents, 2 CLs, the presence of those 2 CLs means that we can also send BP version 7 and BPSec are now unlocked and they can also arrive. So the AD will be getting 4 documents and the Cypher Suites extension. So that's 5 documents. Yeah. We bundled all the work for the last 2 years and sent it as a single transmission.
Spencer got a real free ride. Okay, what's next?
Thank you, Brian.
Where's the agenda?
Next is
Thank you.
BPSec, it said.
This one?
The agenda just now. There is the BPSec interoperability suites. So it's the BPSec update.
Oops.
I don't think we've got it open.
Well, I think that's.
Is it that one?
Is those slides?
Yes, that's the one.
Cool.
Yeah. Okay. Present.
Hi, my name's Ed Bahrain. I wanted to talk about the most recent updates to BPSec and the interoperability cipher suites. The BPSec has been, went through a working group last call. There were some minor changes to it. We had some initial review from a member of the security area. We had some review from a member of an external standards organization security area, and we put those comments back in. And this latest version 09 represents sort of the fusion of all of that. And it's not a lot, but we can go through it. Next slide. And I think we already talked through that. And then the last part is a comment that had come up was that instead of interoperability cipher suites, or as we call them now, security contexts, does need to go forward with the document so that we can do interoperability testing. We did not, and we chose in the working group not to make those contexts part of the security specification itself, but to publish them as a separate document. Next slide. So from the IETF 103, there was a single question that came out of a review from a different standards body called the CCSDS. That review came back and said, your specification of cipher suites is different notionally from how we like to use security associations. Would it be a good idea, IETF, if we were to create a security associations block? And if you did, what would that look like, and what value would it have in the security suite? We looked at it and we drafted it to see what it would look like, and we presented it to the working group, and the working group resoundingly said it's a terrible idea. We think that we can accomplish exactly what we need to without these kinds of large changes and without adding an additional extension block. We agreed with that, having then presented this comment from another group. And so we did not include a security association block in the spec. The compromise was to change some of the terminology so that it was not confusing. And in the security document, instead of using the term cipher suite ID, because cipher suite has a particular meaning to many people, to say security context. And a security context could certainly be used as a cipher suite identifier, but could also be used in a different way, particularly to carry an association or association information. Other than that, there were no changes with the security document. Next slide. And then in following through, well, so there were no other significant changes, and we just went back, and to apply that change, we removed the term cipher suite in those areas. We replaced it with security context. Instead of cipher suite ID parameters results, they're security context ID params and results. And then because we were only prototyping notionally what a security association block would look like, obviously we took all of that out in the -09. And those were the changes, was reacting to that final decision in 103. So BPSec 09 as it exists now has incorporated the comments from the security area, which was simply to mandate that any encryption is signed encryption using an AEAD cipher suite, and to clarify that integrity in this case means signature on open text. And then from the CCSDS perspective, we had gone back and they gave, and actually this might be on the next slide. So next slide, please. Yes, they went back and did one more review of BPSec 09, and their exact word was, oh, this looks very good. So we take that as a positive sign. They had just these comments coming back. 3 of them were minor clarifications in the text, which we will happily make within the next week. And they simply said to clarify a little bit of the language when you say ensure. Integrity services don't ensure that data isn't changed. It just ensures that if it is changed, you can detect it. So little things like that. add CBOR to the terminology list. Just say in section 3.2, we don't allow nesting of certain operations, because if you allow nesting, it's hard to tell when the nesting stops. There were 2 recommendations that we recommend not adopting. One of them is to say, why do you allow security source and context parameters to be optional? Because there are cases where you will not need them, and in those cases, we don't have to go through the overhead of carrying empty fields. And the other is when you say that authenticated encryption is used in BCB, there should be a shall statement in there, not just a note. I think the author missed it. Actually, earlier in the document, there is a must associated with the use of this suite. So I think that the spec actually already does what it's being asked to do. So I don't have a full overview of BPSec 09 because we have gone through it in this working group several times. It has gone through the last call, and what I have done for the past 2 IETF working groups is simply to describe the changes that were made coming out of reviews and how we have responded to them. Other than those 3 comments from CCSDS to clarify some of the terminology, there are no other open comments about the specification that we are aware of. So a question that I had before moving on to I apologize for the title slide, the interoperability security context, is to come back and say, are there any other comments associated with BPSec? We have not seen them online. We do have evidence that there are reference implementations that people have made for this without issue. But at this point, we believe that aside from those 3 nits, we are done. Okay.
One of the open questions, as Rick Taylor here with my chair hat on, is the working group asked Ed to, so the SecADs asked for the interoperability, the Cypher Suites document to be written and to be maintained as a separate document so that it could be updated independently to the main document. The main document has sat in last call at the moment. It's ready to go and it's going forwards. Of course, this document was a personal document until very recently because I forgot to press the button in a timely manner.
I had not gone to that second document yet.
Sorry.
Yeah,
I thought you
there
were
are
on
1 or
that.
2 slides to go on this.
I'll shut up and hold then.
Oh. All of the comments that I made were specific to the BPSec 09 document, that there are no comments outstanding for BPSec 09, and we think that it is ready to go. I will make a -10 version that this week that addresses those 3 terminology changes because I think those are good terminology changes, but it's just an editorial change. Separately, there is another document called the Interoperability Security Context, which had been a personal draft and then was submitted as a working group draft. And the working group had decided that we needed to put that together with the BPSec document so that the reviewers could review both a protocol and an example of how you would define and use a security context. And that second is these suites here. Essentially, the only changes from that context is we changed the terminology from Cypher Suite to security context with the rather notable exception of the title of this slide. We updated the references to point to the latest release of BPBiz and BPSec, and we submitted it as a working group document. And I don't know if I have another slide behind this that speaks what I thought I did.
No, you.
And I was wrong.
Yeah.
So the 2 Cypher suites that we propose as part of these security contexts are a flavor of AES in Galois counter mode and a particular HMAC SHA, I believe 256, which are non-controversial standard interoperability suites that you can use for integrity and confidentiality. The HMAC SHA for integrity, AES for confidentiality. That they also have the benefit of being well represented also in CBOR with COSI, and we were able to point to some references there in terms of how those items would be CBOR encoded, which we'd like to have the CBOR encodings. So we think that those are good interoperability suites, and we hadn't heard any concern from the reviews, the personal draft reviews that we have had, but we would need some review at the working group level of those security contexts.
So continuing from where I left off, the Ed's personal document is now a working group document that was accepted after the last IETF in Bangkok. And I pressed the button very late, but it is now a working group document. Of course, the BPSec itself has been hanging in last call ready to go, and we're now going to send it to the AD. So really, this document was intended to go with it, but it has not been last called yet. Does the working group believe this document is ready for last call? And that is a formal question. We will ask it on the mailing list as well, but I'm judging the room. Our intention is to last call this, get the comments, and then move it on as fast as possible. So people need to be prompt if they have issues. But we'll get that question to the mailing list on the mailing list as soon as possible. That's good. Thanks, Ed. NetConf Ed, NetConf and AMP, is that Jean?
Yes.
That's Jean? Ah, hello, excellent. I don't know where you put the tabs.
This one? Yes. So, hello, I'm Jean Chorin. So I will be presenting the work I've done on interfacing the asynchronous and synchronous network management protocols. Next slide, please. So our network management is administrating and monitoring different sets of nodes on a network. The protocol used are usually very specific for our network. So on an IP network, we would have a protocol would have a low delay, high bandwidth, and we will make use of this. Whereas on the contrary, for instance, on DTN, we don't have all of these prerequisites. So we have different constraints. So on an IP network, for instance, we have what we call the pull mechanism on the left. So we would send a request, and the data would be sent back directly on the reply. On DTN, the way is completely different. We would send commands to have some automation would then send, for instance, what you see on the right on the graph, a report will be sent every 10 minutes. And so this will be called the push mechanism. So both of these approaches are very optimal for their own networks, but they wouldn't work on the other one. So if we wanted, for instance, to manage some nodes on the DTN from nodes present on an IP network, we would either use one or the other, but they wouldn't be very efficient. So what we did was thinking we could combine the two mechanisms. Next slide, please. So our goal was to interface the asynchronous management protocol, or AMP, and the network configuration protocol, NetConf. So we wanted to create a gateway on a node that would be on an IP network and on a DTN, so an interface between the two. We wanted to, for that, we had to translate the data models that are used by AMP, so the ADM, and by NetConf, so the young data model. And finally, our purpose in the end would be from a NetConf manager to be able to send controls to an AMP agent to fetch data from this agent, and then to get rid from the NetConf manager all of this data. Next slide, please. So generally, the architecture is what's presented here. We would have on an IP network NetConf managers that are connected to an interface. On the DTN, we would have the MP agents connected also to interface, but with AMP. So we would have on the left some synchronous call, because requests would have a reply directly, whereas on the DTN side, it's asynchronous requests. Some reports will be sent with some specific rule that have been set before. Next slide, please. So the protocol stack that we used is presented here. A message would be sent from a NetConf user interface, given to the NetConf manager, be sent on the IP network, received on the NetConf agent on the gateway that would be in the interface, read by a NetConf tool that would translate it into AMP, given to an AMP manager, which will give it to on the DTN, and we receive on the agent. And all the way around, it would do the exact contrary. And for this, because we have these synchronous and asynchronous mechanisms, we need to have something to get data easily. So we have a cache on the gateway in the middle on one side to register if we want to have a value, but the value is not available. We would register that this value is needed. And on the other side, when values are sent from the imp agent, then we would store all this value on the gateway in the middle. Next slide, please. So the gateway itself has this architecture. Net messages will be sent on the left to the agents, given to the controller. We would extract it using the information using translation function, then translate it into AMP messages that would be given to the AMP manager. In between, they will also cache the value, and on the other side, when data is sent by the AMP agent, they would be given to the AMP manager. Then the controller will extract all of this data, put it into the cache, and potentially send messages to the netconf managers. So translation approach we're using is presented here. On the left, you have an extract of the ADM for AMP agents. So we have the control here, which is called gen RPTS, so gen reports. These are two parameters that you can see on red. So two are collections of RI, so resource identifier that identifies any AMP element. On the right, we translated this control into an RPC in netconf. So this RPC has also two parameters, which are here leaf list, which correspond to a collection in netconf. So it means all of these parameters can have a lot of different values that would be put in a list somehow. On the bottom, you can see a command that we used. So we, as a netconf manager, we using the Yankli utility. This utility is used as a netconf manager, as I said. So for instance, if we want to send general reports command, we will use it here, this syntax. So the young data module would be read and parsed by this utility, and then it would be allow us to use this. So we have here two parameters. The first would be an RI of value. Like for instance, here we want to generate a report that would send the number of state-based role that are on the ape agent. So to do so, we give as an ID what value we want to generate. Here, the namespace of it, and it's also an EDD, so an externally defined data. And its name is BR. So all of this is put as one parameter. The second parameters are the endpoints of the manager to which the AMP agent have to send the messages. So here we have two of them. We have IPN 4.5 and IPN 6.5. Next slide, please. So this command sent by the netconf manager will be translated as an RPC, XML RPC. So you have it on the bottom left. You have the parameters in the red rectangle. So this RPC will be received on the gateway. The gateway will then read it, parse it, and transform it into the dictionary you have on the right. So this one is an internal dictionary that we use in the gateway. So you can see the aredict all the very specific parameters. So we can see it's an AMP agent, it's a control, the name is, the ADM is AMP agent, it's a control, the name is general reports. Then you have the parameters. First parameter is, again, an RI with its namespace, the type, and everything. Second parameter is the list that we sent before. And this structure is used then to have with a function that will send a control from the AMP manager. And the advantage here is that we could completely do recursivity. So if you have parameters, we have a parameters in the RI that needs to have parameters also itself, then we could recursively add them. So you can see we have 0 and 1, which has first parameter, second parameter, and also we have lists. So if collections have to be sent, then we can send different RI or strings or integers and so on. Next slide, please. When this message will be sent to the manager, to the agent, report will be sent back to the manager on the gateway. So you have here an example of this such report. The value sent will be the 10. This will be stored on the database. Then we have created a Yang module, an external Yang module with several commands to fetch this data from the netconf managers. So we have here get AMP value uint32 to ask for an assigned integer. It has two parameters. The first one, value ref, is the name of the value we want to fetch with namespace, type, and name. Second parameter is the to decide how old we want the data to be. So if we give a small number, then the data too old would be considered stale on the cache. And if we give a very high number, then we can have more data from this cache. So it's the time in seconds. For instance, if we had a data that is less than 1,000 seconds old on the cache, then the RPC reply on the bottom left would be sent back to the NetConf manager with the value 10 and the 3 timestamp, which are the moment the value was requested on the gateway, the moment it was processed on the agent, and the moment it was sent back on the gateway. On the right, if we didn't have any value in the cache, or if the value were considered stale, so too old, we would then wait for a new value to arrive, and the recent value would be sent as a notification, NetConf notification to the NetConf manager. So instead of having a reply that would be ask a request and then the reply would be sent, that would be just like a push mechanism. The message would be sent directly without any request. Next slide. So I will do a small demonstration. I have a video that is on the next slide. So I create an AMP agent, a gateway, and a NetConf manager. I will then start a command to create some data from the AMP agent that will be sent to the gateway. Then we would use another command to fetch this data.
I hope this works.
I hope too. I hope we don't have any advertisements.
It's YouTube.
And the resolution is
hold
very
on.
good.
Hold on. Let's see what we can do about making the resolution better.
It's actually not this,
Right. I hope you can see.
There you go.
Awesome. So I'm using here the MITRE simulator. So an simulator from MITRE called DTM Kit. It combines the core simulator for networks, and it also uses the IAM, so the NASA implementation. I have a very simple scenario with 3 nodes. So on the left, it's on the network, IP network. On the right is a simulation of the DTN. So you have the nodes that moves is a node on the DTN. In the middle, you have the gateway. I have to create some redirections and port forwarding because on NetConf, it has to use the normal IP network. So the nodes on the DTN are considered as another subnetwork, which means then using the line client on the top left, we can connect directly to, as if it was directly to the AMP agent. The gateway on the bottom left, you can see the lines. Several parameters are used. Most of them are for the SSH layer of NetConf. Others is for the directory where all the YANG templates that we want to use are present. So these YANG templates are basically translation in YANG from ADM. So on the bottom right, you also have the NetConf agent, the AMP agent, which is working. So now I'm connecting to the gateway, but as if it was connected to the AMP agent, I'm loading the YANG data module, which is AMP agent. And then I will add a TBR, so a time-based rule on the AMP agent to send regularly some information back to the gateway. So this has several parameters. The first one is the ID of the time-based rule. You can see we can use the YANG CLI type compilation. So the YANG is very this YANG data model is very understood by the YANG CLI utility. So we will send every 10 seconds. We will generate some data on the AMP agent, and they would do it 5 times. So the action here is given as an RI, so an AMP RI, which is the namespace, the type of the command that will be used, the name of the command, and its parameters. So all given as a string. So we have here AMP agent control, we generate reports. So first parameter would be a collection of 2 elements. We will ask for the number of site-based rules on the AMP agent, so not MSBR. The second parameter would be the number of control that had been run on the AMP agents. And this would be the first parameter. second parameter, I give it just simply an empty list, so it would be for send to ask for which manager to send to, so we leave it empty. Here, there was a mistake in the name of the, I did it not on purpose, I would like to say I did, but I didn't. I let it because it's nice, so I can show you that if there is a mistake in the type check or in the name, then we can still check it using the ADM and prevent the message from being sent. So you can see here on the bottom right, that the AMP agent received the message. And in between, we'll look into the database. Also on the bottom left, you can see that the gateway received a message in between. Sorry. So we are here on the gateway on the database on the gateway. So we have all of the ADDs, controls, and constants present there as a reference to when the data is sent, so we can know which elements of the database on the FDM it's connected to. Also, we go a bit too fast, but here I will present all the data that are present on the database, so it would be empty. We have for the moment no data, receive no data. And yes, so here I actually had to cut the video because it took 2 minutes, so 2 round trips for the data to arrive on the manager, on the gateway. Here we could see we had more data that was present. So 4 already, reports has been received on the gateway. And if you use the special yang command that we created before, that I was explaining before, then we can ask for inside integer. So we will ask first parameter for which we say which value we want to have. So here the AMP agent EDD number of control run on the AMP agent. And I will write here a small cache timeout to show you that if we write a small cache timeout, then there is not enough more recent data to be sent, so just a previous reply is sent. But if we increase this cache timeout, then we get the most recent sent data, again with this 3 timestamp that I explained before. Oh, no, sorry, but here is the cut in the video. And now we have here more data, and we have 2 request values that have no value. So this is just registration to say we want this value. We still don't know what exactly is the value, but we want these names. And in between, the values have been, so this message to ask for the value have been sent to the AMP agent, and then reports have been received for updated value, and you have here notification. It comes notifications, and yes, so with the updated values. You can close the video now. That's.
Oh God! How do I get out of this? Back? Is it? No. I'll try pressing back. It's a Chromebook. Something's going to happen. There we go. Is it? You draw.
So in conclusion, we'll be able to send any control defined on an ADM using netconf. We can also have, in these controls, we can have several parameters that we use, so parameters, in parameters, and so on. And we can retrieve the data from the gateway directly using netconf. And also, if some data, new data is arriving, then the notifications are sent to the netconf manager. Next slide, please. So there's still future works. Obviously, so currently the focus is on supporting the table templates from MP, which are heavily used in some ADMs. So we want to be able to get the report and retrieve and letting also make it available for the netconf manager. Also, we reduce the scope to having only one gateway here. If you had several gateways that could be connected all together, but so connected to the same DTN, then we need to have some synchronization between all the gateways, which was not the focus of this work. And yes, so we have also a rationale to calculate the cache data, how long we have to wait. We have default values for that. Also, if the data is in the certain acceptance range arrive at the right time, then we return it directly without asking for a new value. This issue here is that we hard-coded the value because it would be then a new work for optimization, and this is not the focus also again on this work.
Any questions?
So just Ed Barain, I just wanted to make one comment on the work, which was the other part of the optimization you would see is the need to currently interface with the AMP manager, which is what is bundled in ION right now. That is not the cleanest way to interface with something, as maybe you would understand. But there's other work going on to create either an RPC interface or other kinds of interfaces that would be more amenable to that. So the other part of the optimization is some of the stack that was shown had things in there because of the necessity of working with an existing reference implementation.
Yeah.
Hi, Eric Voigt, Cisco, good stuff. Question for you on netconf and protocols that can do locking or have multiple clients connecting. Did you look at all about or have any thoughts about how to handle when you do a database lock on one side and queuing up transactions?
I haven't. I know about it. I know that netconf is usually supposed to have some commits on the database and everything. So I have some small support that if a command is done at the time and all the data, the other are waiting for it to be done. This is not as developed as in the real netconf database, but this is definitely something that is in the development. Yeah.
Rick Taylor, I actually have a question for Eric Voigt, who's just asked, who I happen to know has finally got his Yang push drafts through netconf, which is, as I understand it, and I am not a netconf expert, it's netconf notifications on steroids, really, isn't it? Do you have any advice for the guys working on this on whether it's that push-pull thing you started your presentation with suddenly made me think of the work that Eric's been working on, and whether that interface could be more elegant?
I think we could probably talk offline some. The netconf notifications, there's two types. You can push events with netconf notifications, and the stuff that Yang push does, which is you can subscribe to data store elements to get push on change. So this is less relevant for writes, because we're looking more at how do you push on a subscription changes to the data store in the back. So I think that the difference between events, which are when an application knows something has happened, versus data store when some recipient cares to say what they want to receive, are different data sources, and both can be relevant.
Comment, just Ed Barain again. But so I agreed, but in the example that was presented here, there was a command to say, go generate this value, every X amount of seconds or minutes or days for this amount of time. And then a separate query had to come in and say, that's been running for a while. Now I would like to see if that data has changed. Yeah. And then you get the data cache timeout, which says, hey, do you have a new version of this that is not more than 10 seconds old? And that would be a way to do it, and sort of a standard netconf way to do it, I believe. But if you had something like what Eric has been working on, you could say, generate this data every 10 days, but whenever the value changes, send it to me. And then that would also help with that push side of the, we talk about push and pull, but you don't always know when to pull, and this would help you understand when to pull.
Yeah, so Rick, again, so I think summarizing from my own sense, you're saying the gateway's data store subscribing to Yang push notifications on the gateway data store, which is being updated by the AMP management system, but your downstream netconf system can say, oh, hey, the AMP subsystem has changed the data store in the gateway, and therefore I am now receiving notifications of updates. Yeah. Sorry.
So comment Ed Boreen again. The issue that one runs into is when you're trying to manage assets that are disconnected from the network for a long period of time. And why we wanted those time-based rules to begin with was you wanted to say to the disconnected agent, make sure every 10 seconds you're producing this value with the appropriate timestamps and with the appropriate history. And then when I come and see you again, and I haven't seen you for an hour or a week or a month, all of that appropriately time-stamped historical data comes down. And so the one thing you have to be careful of in the push case is, do you get nothing for 10 days and then 10 days worth of information coming at you all at once? And that's really the only reason why you might not want to do that.
10 kbit per second.
Yeah.
What fun, what great discussions. Yes, in this case, if you're doing that, I would suggest use not subscribing to data stores, you subscribe to events. We actually built the protocol so that when you log in, it will give you the history of events, even previously created events, as a replay capability. So you have the ability, even if you lose connectivity, where it will actually give you a new start from a last event that was sent. So it's been designed for filling in gaps.
Yeah.
Magnus Westlund. I have a question here. How big or how much risk for troubles because of the nature of the DTN is this type of, if you request something to be produced and then you actually, what's being produced exceeds the delivery capacity of the DTN, what happens then?
I'm looking at Ed to try and answer that.
Magnus, while Ed is going to the mic, it's not a new question you're asking. It's been discussed.
So the short answer is there is no mechanism to say don't overdo a quality of service that's in a DTN because it's not always clear that you understand what that breaking point is. The way that AMP talks about it in terms of DTN is it will create bundles. It will, so the way that AMP addresses it as a protocol, separate from this demonstration, is to say that we try and have very compact encodings. We try and bundle data that is going back to an agent or going back to a manager to not have duplicative data, which is interesting in the sense that it is an open loop approach. So if I am constructing a bundle to go to a manager, I will put all data destined to that manager in that one bundle, even if those data were produced as a result of different requests from that manager, so as not to go through those overheads. And then lastly, because we put it into the DTN with a given quality of service, how it gets back then becomes an issue of the data within the DTN, just like if you had an instrument that was producing too much data. Except that the management data may be of lower priority because it could potentially be regenerated.
Mark here, I have a question for the speaker. So my understanding is you have somewhat implemented AMP or parts of it to do your translation.
No, because I use basically the AMP manager exists. It's CLI somehow, and I have a Python script with Pexpect, which just reads what is happening and then writes the right value. So
I was hoping you would say I have implemented most of AMP, and this is a different implementation of it.
No. He did all the work.
Nice one.
But Mark raises a very important point, which is although the AMP work officially comes post our sort of phase 1 DTN charter items, I know we have a current charter item on the architecture of management in DTN, but there's been a lot of interest around what Ed's been doing, and his team have been doing a lot of work, and it's a proposal that we should look at AMP and work on this as part of kind of phase 2 of the DTN working group. Currently, there is only really one implementation. So those of you who are grad students, have grad students, are just generally bored at home of an evening, having fun trying to build an AMP agent. That would be of real interest to the working group. Otherwise, thank you, John. Next up.
Next is Ed, I think.
Yeah,
That's the one.
So, hi, I'm Ed again. And well, the two things I work on were security and network management. We had talked about security and we had started talking through network management. I did not have a video and was not clear to me that I could share my screen. So what I have is a series of screenshots, and I apologize for that, but either John or I could if anyone wants to stop at the end of the meeting and get a live demo on either of our laptops, we can show you what is going on. We have a set of specifications. They are personal internet drafts right now for an asynchronous management architecture, data model, and binary encoding and protocol. And we've broken those out as 3 so we can reason about them separately. Within ION, which is an open source, within ION open source, which is an open source implementation of those protocols, there is a fully compliant AMP manager and AMP agent. We are talking with folks who maintain DTN2, who will be building an AMP agent. The thought is that if you build one AMP manager, then it can manage any agents, regardless of whether they're in ION or DTN2, but we will have at least 2, and then other space agencies, CARI, DLR, are also considering their own AMP agents, and there are at least 2 different efforts currently to build alternative interfaces into an AMP manager, one being a web interface, another being something that's driven out of SQL and SQL tables. So there is some sense of what is implementable and how easy or hard is it to implement, and what features would we get out of it. What I wanted to talk through, and we can go to the next slide, is what we're doing under ION as a reference implementation. So just a few reminders. The things that are presented here are based on either personal internet draft or something that you could, and all the software certainly can be downloaded off of SourceForge and looked at. Just as a piece of terminology, I know that I see a lot of new faces in the room. I know we had talked about network management, asynchronous management in the past. We draw a distinction between the architecture and asynchronous management architecture, AMA, which talks about why we need time-based and state-based and other kinds of functions. And then we have a data model. And the data model says, here are the 9 types of data that we need: tables, reports, strongly typed variables, and so on. And this is how you would use them and why they should exist and why it's not duplicative with other elements of a model. And then we talk about a JSON encoding of that and how you could represent, we call them ADMs, but we could think of them as MIBs or Yang modules in the function that they serve. A JSON template for their specification so we could write tools to ingest and operate on them. And then the AMP is simply a CBOR encoding of those models separate from a string encoding or a JSON encoding so that we could have more efficient messages on the wire. Within ION, there is a network management subdirectory under the main open source directory called NM, and that's where all of the AMP implementations live. In docs, ADMs is where the JSON ADM files live, and in contrib, camp Python is where a particular code generator is, and I'll show you some screenshots for that. When you build and install ION, you get a manager and an agent that you can run. Next slide. If you want to start the manager, you start it by typing in nm manager, and as a courtesy for bootstrapping, just in this reference implementation, you give it, you tell it what EID it should have. It will come up. It will read any persisted definitions from the ION simple data recorder that is there, and then it gives you a glorious text-based interface for which you can type text to your heart's content. And while it is functional, and we can walk through it, if anyone is so moved to continue to create alternative interfaces into this, we would very much like to help and support and encourage that. Next slide. The agent similarly is started up on the command line. Again, once ION is running, you've done a make install, you get nm agent and nm manager. The agent takes its own EID and a default manager. In the previous presentation, there was the discussion of the receive managers. If you don't specify a receive manager, it goes to a default manager, which you can specify here. It also comes in, sets up, and then when it does, it sends a registration message to its default manager that says, hello, I exist. It's not required. You can go in and tell a manager that agents exist, but it's a courtesy. Next slide. So what can you manage on the agent when you go into this text-based interface? You see the agents that have come up. These are the ones that, this is the auto-registered one. You can forget about the agents and you can print reports or persist reports that come in, and then you can really just do commanding, which is mostly what you want to do anyway, and that's under build control. There's the ability to send raw hex to the agents as well, which is something that we just have as sort of an expert interface so that we can capture and replay things. Next slide. So what does ION support? Right now, what we have done is generated JSON encoded ADMs, which are also published as personal drafts for the agent ADM itself, which is, this is the ADM all with the controls and the data and so on that every AMP agent should be able to understand. And then we have done that similarly for a generic bundle protocol agent, a generic LTP agent, and a generic BPSec/SBSP agent. And then we then created a set of specific ADMs for ION itself. If you have ever used ION, you know that there are multiple, not too many, but a couple of administrative functions that you use to control IPN admin, IONSEC admin, BP admin, and you can control ION by SSHing into the machine that it is running on and running these commands. But in this way, we took essentially the man pages for all of these, created ADMs, auto-generated the code. So now you can control multiple instances of ION on different agents over just a bundle interface, using the AMP protocol. Next slide. So I'm sorry, just go back one. So in general, that's not a very large amount of data. It's somewhat large for us. Where we are now with these protocols, but it's 158 data definitions, about 94 controls, 22 tables, and so on. Next slide. So if we take just a few examples, if you are in that interface and you say, go show me all of the controls that come out of, say, the BPSec interface, that's the window on the right. A zoom in of just one of them is on below, and it's the example that says go add a BCB rule, which in ION is a rule that says if you are sending a if you are sending a bundle from source to destination, and it has a block type of that particular target, it must have a BCB, and the BCB must use this cipher suite ID and this key identifier. And you can then start playing with those rules and security configurations and policies separately over the AMP. Next slide. We have tables. Here's an excerpt of tables for a generic BP agent. One of the tables, we call them table templates, is, for example, outducts. If you are configuring ION and you would like to get a general dump of what are the endpoints, what are the inducts, outducts, protocol supported schemes, and so on, you can generate that information in a table format and get it pretty quickly, and it's just a nice way to parse that remotely. Next slide. So here would be an example of a poorly ASCII formatted table result coming out of the text interface, which is if you just bring up a loopback interface, one of the loopback interfaces that is bundled with ION, you will get, in this case I used STCP, but this would be the outducts that are auto-configured on ION for STCP. Next slide. And then you also have report and report templates. They are a bit like tables. The difference is that in our model, users can generate custom reports as well that pull in data from various other ADMs as they need to. And you could parameterize reports. And that bit of associative lookup was pretty motivating to the use cases that we had. So the generic BP ADM has two reports. One is a full report, which is all the stuff that we know about that is specific to the agent, the overall node for the agent, and then a specific endpoint report that says for every endpoint, here are a couple of pieces of information that we track separately. Next slide. We can certainly request a report. If a report comes in, we can print it to the screen. It has it has 43 data items in it. But a data item, just like a report, can also be parameterized. There are cases where it is helpful and useful to do that and cases where it is not. An example of where we use it And the available storage here is a configuration issue. I don't actually have that much storage on my machine. That would be tremendous. Well, to some unit of measurement, I'm sure that I did. But if we look at, for example, bundles by priority, that's a piece of data, but you give it a mask. And you could say, give me the bundles by priority for all priorities, or just for low priority, or medium priority, or high priority. In the JSON ADM, when you specify this, you can specify, I would like this data item with this particular hard-coded parameter, or with a parameter that flows in from somewhere else. In this case, the full report has no parameter, and it outlines these as they are. And that's how you get that particular data, and we do it one for each priority type. If we go to the next slide, you would see an endpoint report. And on the slide on the right, you would ask the agent to produce an endpoint report for, in this case, IPN 1.0, 1.1, and 1.2. And it would come back and say, the endpoint report itself has taken a parameter, IPN 1.0, and it contains 3 pieces of data which themselves are parameterized. And the parameter in the report flows down to the parameter for each of these data items, and it pulls it out. We particularly like that because we don't always understand how many different types of things we will have, so we don't always size a static array. We also don't want to have to do one spin of understanding how to match to an array index a particular associative lookup, and we like the idea of being able to put the associative lookup in the request itself. Next slide. So if we look at then what the JSON files themselves are, so in this case there's one called the SBSP in IETF, think BPSec agent. And this is how you define a control right now. We've tried to keep it simple as possible. You have the name, you have the parameters that it takes, you have a description. There is some other metadata associated with the ADM itself. I'm sure there may be over time some other things we would like to add when we define a control. We are all ears for that. But again, the BCB rule takes 5 parameters when sending from source to destination. This target, use a BCB with this cipher suite, security context at this point, and key name. Next slide. BP endpoint report, parameterized report. You're able to come in and say, I have a report, and the report itself takes a parameter in its definition. And the report template will have 3 pieces of data in it. And each of those 3 pieces of data also happen to be parameterized, listed somewhere else in the ADM. And I would like to flow the endpoint ID parameter into the definition of the ones that contain the report. So what is interesting about that is the ADM has a way of specifying whether and how you flow parameters into contained objects, and then you don't have to worry about that when you auto-generate the code or when you specify it in some other way. Next slide.
Can I just jump in there? Because I know from my conversations, because I'm pretty dumb when it comes to these things, the parameterization is a very strange concept, and you wonder why all this effort has gone in. The reason is to make sure that pretty much all these requests are one round trip. Because unlike this is a DTN, it's got to be one round trip, because you could have 4 hours of latency on this. I'm particularly looking at guys with a netconf background where you say, oh, how many items have I got? Great. Get me item 1, get me item 2, get me item 3. Sorry.
No, it's appreciated.
It's an important point.
And it is also a point that we have talked about in the AMA document, which is sort of our architecture and reasons and rationale for why we made some design decisions. Although we're certainly happy to revisit any of them and talk through them. Next slide. Then if you have these JSON scripts or these JSON files, we package a Python script with the ION open source. It lives in nm/contrib/camp Python. It is a C API generator for AMP. And if you have it, and you can see in that first instance, if you type camp, you'll get the usage out of it. The minimal usage is you type camp in the name of a JSON file, and it will auto-generate some ion.h and .c files. If you had previously auto-generated and hand-tooled some .h and .c files, you can give those as parameters back, and it will carry your changes through when you do updates and that sort of code round tripping. And what it will produce in an output directory of your choosing are 5 .h .c files that can be compiled into ION to help with its adoption. Next slide. So it will create an agent directory with 3 files that get compiled into an agent. It will create a manager directory with a file that gets compiled into a manager, and then a shared .h file that can go between them. What's interesting is that the manager file does not need any user edits. It has all of the information in it as is, and you don't ever need to look at it again. The agent has one file that is non-user editable, and then two files, a .h and a .c, where you go in and put implementation information in. Next slide. And here's an example of what that looks like. The only thing that you have to provide an implementation for, or things that you have to provide an implementation for, is if you define a function, you have to provide the body of the function. So this would be an example of a function definition, add BCB rule, and the stub that would be auto-generated for it, and the place where you would put your custom implementation. Next slide would just be an example of the custom implementation coming out of the ION open source to actually add a BCB rule. We have some API parameters for extracting and validating parameters, and ION already has an ION secadmin function that performs this purpose, and we just pull the parameters out and call the function with some error checking. Next slide. In addition to, if you define a function, you have to give implementation for the function. If you describe a data value, you must find a way to sample that data value. We had, for example, in the BP endpoint report, one data item was whether the endpoint was active. This is the kind of stub that is auto-generated for a defined piece of data. If you then go to the next slide, you'll see an implementation of how to go get and return that piece of data. The last one, and I don't have an example for it here, although it is there, is a table. If you define a table template, you need a function that will populate and send back the table. But otherwise, for reports, for macros, for variables, for time-based rules, for state-based rules, there is no user action associated with that. You implement functions, you implement data collection, you implement tables, and then everything else is auto-generated and compiled in for you. And it has made the adoption of these ADMs in ION go quite quickly. And next slide. That might be it. So that is where we are. There is a reference implementation in ION. There are scripts that will parse JSON ADM files. The formats for all of these, the AMP and the CBOR encoding, the ADM and the JSON template, the overall architecture and the design decisions, and all of the ADMs that we have talked about, which I think totals about 15 documents, are available, and they are published as, I think, personal IDs, but I think you can get to them in some way from the DTN page. So if anyone wants to see anything else, I'm happy to show it to you on my laptop, but otherwise, thank you very much.
Thank you, Ed. Hackathon.
Yeah, so it's either Boris or Martin. I wasn't sure who was actually presenting. So these are the guys who've been doing some work at the hackathon on the PYDTN implementation and wanted to tell us about it. It's here somewhere.
Hello, my name is Martin Pilka. I'm from XWorks, and we are working on hackathon. We did some work we would like to present to you. We do have implementation of PyDTN, which is a Python implementation of some basic DTN stuff. And also we are communicating with MicroPCN. So this is integration work. And MicroPCN is developed by D3TN network from Felix Walter and Marius Feldman. Next slide, please. So basically, this is the presentation we showed on the hackathon. Our use case is very simple. We do have 2 ground stations, and we would like to communicate with each other. They do not have any other means of communication, just the satellite, because they might be located on different planets. Actually, we are not planning to locate them outside of Earth in 2020. So the use case is that actually ground station 1 get some sensoric data like temperature or similar, encode them into the bundle. Then eventually, when the satellite is in sight, it will send it over DTN, bundle protocol version 7. Satellite will not see the ground station 2 right away, so it will have to store this bundle somewhere. And eventually, as it continues on the orbit and it will see the ground station 2, it will send this bundle. We are still discussing whether we are going to use beacon approach or whether we are going to use that would be opportunistic routing or deterministic. That's under discussion. But for the purpose of this presentation, what we implemented is that we have one Docker container per object. That would be ground station 1, 2, and satellite. And ground stations are running PyDTN, and satellite is running microPCN. And we have some demo which you can see on the laptop if you are interested. But this really works. Next slide, please. So we are touching three drafts here. Bundle protocol version 7. Then there is TCP/CL convergence layer. We are working with the old version. Old version, well, not the one discussed today, the previous version for now. And we are also using IPND. Actually, there's a plan to use IPND. Code has been written, but it's not used yet. We identified some issues there. For example, the IPND draft is expired, but we would like to see that up to date because it would simplify testing of our approach. Because as far as I know, and please correct me if I'm wrong, we are not aware of any other way how to network discovery, neighbor discovery could be done, except this already expired protocol. So that was the issue we were trying to address on the hackathon. And our solution was that let's check if the document is still up to date. Now I mean IPND document, and bring it back to life. Maybe up to date means like, okay, it is expired. That's something we know, but maybe the information contained inside is still valid. So that's what we're trying to confirm or reject. Next slide, please. So this is just an information slide for the hackathon purposes. We basically improved our implementation, and you can see our code if you are interested. It's publicly available on the PyDTN link in GitLab. Next slide, please. Yeah, this is probably the most interesting slide of this whole presentation, which would be the feedback to DTN workgroup. We would like to see IPND draft up to date and possibly adapted by workgroup, unless there are some other means how we can do the discovery. Because what we are doing today is that if you want to test cooperations of multiple implementations, and there are some, for example, there is this, as far as I know, implementation in Go language, just recently showed on the email list, and there is Java implementation. We are able quite easily to put them into container and communicate with them, but they do not know easily about each other because this IPND stuff does not work. Then what we noticed actually that IPND uses SDNV for encoding and decoding numeric values, which is kind of different approach from what we are using in bundle protocol, where CBOR is used. So if the workgroup decides that the IPND draft should be brought up to date, then probably this would be one of the things which should be fixed. It should be CBOR, most probably in both drafts to be consistent. And then there was this recommendation from Felix that IPND currently, obviously, it depends on IP, but it would not have to, because the IP requirement is not kind of. It would be possible to extract that. So we would have something like not IPND but DTN-ND, which still can name what that would mean in IP world, but it would also support future CLAs, which currently is not the case. Other option would be like what we have today, that there would be one draft per CLA. That's also an option. So this is something we would like to discuss today. Feel free to express your opinion. And that's it. Thank you for your attention.
Thank you very much, guys. Rick, chair hat on. Neighbor discovery is an active charter item. And I know about shortly before I started as a chair, people were looking at neighbor discovery. I was a proponent for, I agreed with Felix that I think a DTN-ND using CLAs and maybe event-driven would be a way to go. I know there were other people in the room, Ronald, for example, who wants to go the other way. So there's certain input doing it. If you want to volunteer to start working on it, it would be very welcome.
Yeah, we are volunteering
needs
to
to
do
happen.
that. If there is a will that work group wants to have this standardized, we are happy to
It's a
participate.
charter item.
Yeah.
We have to have it. Sorry, we have to have it standardized. We've agreed.
So we are volunteering to do that. Well, we'll see. Well,
at least start a discussion on the mailing list after here. But yeah, I think people want to talk about it. But even an opening draft of here are some ideas I've had, and we'll start the conversation.
We are especially interested. Okay, well, it seems we are in kind of agreement regarding first point that we want to have the draft up to date, and regarding second point possibly as well, that this SDNV should be removed. Regarding third point, what do you guys think? I mean, is it a good idea to remove the IP dependency in IPND graph and call it DTN-ND or something similar? Do you think this is not no way to go?
Mark here. We all know that DTN may not work, may not be transported over IP anyway. So
that's true.
So
but
that's obvious. So
you know the way why we are actually interested into this is that it allows us very easily to test our application level changes with other implementations. So that's why we care. And well, so you made a point actually that the TCP/CL is going to be the only convergence layer for. Yeah, that's a valid point. That's a valid point. What do you think, Felix? Actually, this was the point proposed by you and Mark. Yeah, well, we have some people in the queue already.
Yeah, I was about Ron Infeld. I was about to say that the only convergence layer adapter that we have so far is IP based.
Yeah.
So I'm not saying that IPND or DTN-ND should be the only game in town. You can do other neighbor discovery protocols later. But I presented this in Buenos Aires and it was killed within 5 minutes then.
Which year was this?
2016.
Okay, so.
And I'm happy to bring this back to life and work with you to do those first 2 bullets and have a draft out before Montreal.
Cool.
But if this is going to be something with a new architecture, back to the drawing board, let's do a very generic thing, then I'm often not interested. Thank you.
Okay.
Rick with chair hat on, there's nothing to stop us doing both. I see real value in refreshing IP neighbor discovery, making progress on neighbor discovery, particularly as there's interest here in the room. Great, let's do it. If in parallel people want to have a long esoteric argument, I'm happy to join the long esoteric argument on the mailing list. And hopefully that might, well, it probably won't be productive at all, but it'll keep us all busy.
Okay.
I can do one and somebody else can do the other.
I'll do the other.
Stan Ratliff here. I'll sign up for the esoteric argument on the emailing list. I've got a lot of heartburn, and I don't think I'd be the only one in having a non-IP based solution coming out of the Internet Engineering Task Force.
Yep.
Okay? No.
But, however, Rick here, there are other SDOs, such as CCSDS, I can see Scott standing behind you in the queue, who will standardize through their own body convergence layer adapters, and they're looking to the IETF for guidance on, given the IETF owns BPBIS v7 and is driving that forwards, then that defines the behaviors of a CLA.
If you want to put an architecture together on this neighbor discovery so that you can slide different transports underneath it where IP is the one we're doing here. And somebody else may do it in some other SDO may do it in a non-IP fashion. Great. We can all get together and knock our lights out on that one. But out of this standards body,
it's got to be IP.
Well, I'm going to lobby for it until they tell me to shut up.
Scott Burley, I think I'm in strong agreement with that last comment. Is that I don't see any obstacle to having an architecture that that draws a clear interface between the portion of neighbor discovery that is the exchange of the discovery information and the portion of neighbor discovery that is establishment of the connection over which that information flows. And the latter, obviously the first one to build would be an IP-based substrate for neighbor discovery. But I don't see any advantage in having a proliferation of vastly different neighbor discovery protocols for different environments. I think it makes much more sense to have a standard data exchange of neighbor discovery information and separate from that, connected through an interface, through a well-defined interface, the convergence layer connection establishment, connection management software that would initially just do IP, but could in the future do something like Bluetooth, Wi-Fi, and not necessarily rely on IP. I think it would be a mistake to require that that the only product of neighbor discovery development be something that only does IP and will never do anything else.
Mark here. So it's great to see, Mark as a chair, great to see people interested in the next topics, because neighbor discovery is one, and addressing architecture and a few others have been, sitting there waiting for, the basic work to be done, which we're done almost. I have to remind that we also have LTP as an RFC that was discussed here, right? So we're not only IP.
Just one short note. This is Martin Pilka again. Just one short note from what Scott said. We had a lot of feedback on the hackathon. People coming to our group asking like, "Hey, can we use this in IoT world? We have this problem that actually we cannot see our sensors all the time." So there seems to be an interest from industrial part of the world of using this, because right now they do use some proprietary things. So actually neighbor discovery might not be needed only in IP world, but maybe also it could be over Bluetooth or something else. I agree with that, and yeah, that's it.
Thank you very much. I think we're done with the agenda.
Thank you very much for your attention. So whoever wants to see the live demo, please come to us. Thank you.
So I took a few notes of next steps. So BPBIS chairs will send the request for publication. Our shepherd Fred would be writing up finally. TCPCL v4 Brian will post the last version. Quick change. Chairs will request a publication. Ed Bering Shepherd will submit the Shepherd write-up. BPSec Ed to post the last version. Chairs to request for publication. Scott Burley to do the write-up. Minimal TCPCL, we will have to do a working group last call because we haven't. So we will do. If everything goes fine, we'll request for publication. We will be looking for a shepherd for this MTCPCL document. Might be premature, but if anyone is interested in volunteering for this. Ronald? Okay, we'll find. BPSec interrupt. Chairs to do working group last call. We haven't done a working group last call on this one. If everything goes fine, request for publication. We need a shepherd. Anybody? I have someone in mind. The same shepherd that does the BPSec, because it's kind of the two documents. Would you? Cool. Scott, do. And, you know, that would be a good result to do all this. And I guess probably at that time would be a good time for chairs and the working group to actually revisit our milestones. And we actually started this with, you know, a topic of interest, which is neighborhood discovery, and obviously management would be another, you know, clear possible milestone. So we'll have to, you know, have a chat on this, and I guess the chairs will start that discussion, you know, when the whole pile is gone. Or
I think it's probably worth getting through those last minute panic comments as we get the documents out the door, and once they're safely nestled with the IESG, then we can start a discussion. I'd also say I think we've got to start tackling addressing fairly soon, because we're pretending you don't need to name anything, but you do.
Any last comments?
Sorry, just Jean Chorin, just forgot to say that I have what shown on the video is present here on my laptop, so if anybody wants to play with it, can just come to me.
From Rick, one last thing other than thank you is a big thank you to the hackathon guys and the guys showing running code. You go to a lot of IETF meetings where people are talking about the status of drafts and then everyone types on their laptops. It's really nice to see stuff happening in the working group involving running code and that kind of stuff. I personally really like that kind of thing, so big thank you to you guys. Otherwise, are we done, Mark? Yeah. We're done. Thank you very much, guys. Thank you.
Blue sheets.
Blue sheets. Everyone signed them. Sorted. Goodbye. Excellent. You got it.